cos of an angle is the x value of a point on the unit circle, where the angle is measured anti-clockwise from the positive x-axis. So if we want to get the cos of 142.72 degrees, we look to the x value of this point here. So we see it's minus 0.8. So when x is this angle here, which in radians is 2.49 radians, then y is going to be minus 0.8. So in the graph of y equals cos of x, x is assumed to be in radians. So here we have one point on the graph, and we can generate more points by increasing angle x, and we just note the x value of this point. Now this x has nothing to do with this x here, so don't mix them up. The x value of this point here is minus 0.46. That happens for an angle of 4.23 radians. So a point on the graph has coordinates 4.23 comma minus 0.46. So the y value of this point here is actually the x value of this point here, if you want to compare them. Let's look at the trace of this point. I'll just bring it back to 0, bring x back to 0. Now the cos of 0 is 1. So when x is 0, y is 1. So we are just going to look at positive values of x. So the graph is going to start here at this point with coordinate 0, 1. Now let's increase x. Well, we can see that the cos function is positive. We get 0.91 for the cos of 0.43 radians. So I'll keep on increasing x till we get to 90 degrees, which is pi over 2 radians, or 1.57 radians. We can see now that the cos of pi over 2 radians is 0. Let's look at reflex angles. For angles between 90 degrees and 180 degrees, we can see that the cos function is negative, so the graph is going to be below the x-axis. Also, using the cast rule, we're dealing with angles in the S quadrant. So in this quadrant, only the sine function is positive, which means that the cos function is negative. So the cos function is going to be negative for all values of x up to pi radians, or 180 degrees. Well, actually it's going to be negative into the t quadrant as well. It's just going to reach its minimum. The function will reach its minimum value when x is 180 degrees. It's still going to be negative. So for example here, when x is 3.96 radians, the cos of x is minus 0.68. So when we get to 3 pi over 2 radians, or 4.71 radians, we see that the cos is 0. For angles between 270 and 360, the cos function is positive. We're in the C quadrant. Now I'll keep on increasing x till we get to 360 degrees, or 2 pi radians. We can see that the cos of 360, or the cos of 0, is equal to plus 1. So we have completed one cycle of the cos function. If I was to continue on with angles greater than 360 degrees, we would just get a repeat of this cycle here. So the period is the smallest interval over which a function repeats itself, or we could call it period to cycle as well. In this case it's 2 pi radians, just like it was for the sine function. We can also see that just like the graph of y equals sine of x, the range of the function y equals cos of x is from minus 1 to plus 1.